So let's take a look at one like number 77D, or actually it's exactly 77D, I'm sorry. Let's see how to do this one. The function was 4x cubed plus 5 over the interval 0 to 1. And we're going to rotate this curve about the line y equal 10, which I hope you realize the line y equal 10 is a horizontal line, not a vertical line. All right, the value of y is constant at 10. X can be any value, so that's a horizontal line. And we're going to be using the disk or washer method. So the first thing you want to do in these problems is to sketch a graph of the function and look at the region that you're rotating about, in this case, y equal 10. Okay. And so if you have graph paper, that works. If not, you want to be real careful. Even draw a ruler, use a ruler to draw lines as straight as possible. Some of us have more challenges than others in drawing straight lines. I know I'm one of them. So using a ruler can be helpful. But try your best to scale it correctly. Doesn't have to be perfect, but it certainly helps, because if you're really off, then things can become confusing. So you do want to realize that the function's value at 1 is 9 and at 0 it's 5 if you evaluate it. And of course you should recognize this is a cubic function. I don't want to graph the whole function over its entire domain. I'm just interested over the interval from 0 to 1. From 0 to 1, I'm gonna think it looks like this. Now it might actually look a little different. It might curve, instead of being concave up, might be concave down. But in this case, it's going to be fine as far as setting up the integral needed to find the volume. So I shaded in this region here, and then I'm going to rotate it about this line y equal 10. Okay, y equal 10. So what's that going to look like? Imagine this piece, going and coming out of the page and rotating around and going back into the page and so on. There's going to be this sort of conical hole through it here, right? If we're looking at either from this direction, from the right or from the left, we're going to see a big hole that sort of, not conical, but parabolic shape, I guess, almost. But of course, it's not parabolic since it's cubic. But anyways, that's a difficult thing to do, to visualize. I mean, the book does a good job of showing what the three-dimensional shapes look like. So I would refer you to the book to do that. But the important thing is, when we look at an arbitrary rectangle, so come out here to an arbitrary value of x and look at this rectangle and rotate it about, right? What's going to happen? We're going to get a washer, right? So this rectangle would be, say, right here, okay? And it comes out of the page and then back into the page, right? And circles around y equal 10. So coming right out of the center of this is y equal 10. Okay. And so, this is a washer. The area is going to be the area of the big circle, which I'm going to call radius big R, and minus the area of the hole, basically the little circle, with radius little r. I think the book might use r sub 1 and r sub 2 sometimes, different notations, but that's the notation I'm going to use. So how do you find the value of r? Remember, r goes from what? From the axis of rotation actually to the furthest point from the axis of rotation, right? Which would be, in this case, the bottom of the rectangle. So the bottom of the rectangle goes around and forms this bigger circle. The bottom of the rectangle does that. So the total distance is r. What is that? Well, in fact, it's going to be a fixed distance, but in general, you always define the distance, not multiply, but subtract the top value, which, notice that's y equal 10, minus the bottom value. What's the bottom value? Well, you're on the x-axis. What's that? That's y equals 0. In fact, right, the x-axis is y equals 0. So, I mean, obviously you can just write 10, but I'm just showing you in general, this is the way to go. 10 minus 0 is 10. So that's fixed always at 10. But little r changes. The top value of little r is 10, right? Y equal 10. But the bottom value is on this curve, right? What is this curve? This curve is the function 4x cubed plus 5. And so 10 minus the quantity 4x cubed plus 5 is going to give us the value of little r, which is the radius of this hole, basically. All right, it's the inner edge of that disk as we rotate this rectangle about the line y equal 10. Well, now we do a little algebra to distribute the -1, combine like terms, and we get the value of little r. So the volume is going to be to integrate this cross-sectional area from where? We said over the interval from 0 to 1, from x equals 0 to x equal 1. We're integrating with respect to x. All right. Capital R squared is going to be 10 squared. little r squared is going to be the quantity 5 minus 4x cubed squared. So we do need to simplify before we integrate, right? Which is to go ahead and square this thing out. I hope everyone by now can square a binomial. 5 minus 4x cubed squared is 25 minus 40x cubed plus 16x to the sixth. I distribute this negative, I get negative 16x to the sixth. Negative times negative, positive 40x cubed. And remember, this is 100. 10 squared is 100 minus 25. 100 minus 25 is 75. So there's simplified result there. And then, it's just a matter of now we do the fundamental theorem of calculus. We find the antiderivative, right? The antiderivative of negative 16x to the sixth is negative 16/7 x to the seventh. Antiderivative of 40x cubed is 10x to the fourth. Antiderivative of 75 is 75x, just by the power rule. And make sure you notice when we're integrating, right? Here's the integral sign. When I write the antiderivative, there's no integral sign. It's a valuation bar, right? From plug in the upper limit of 1. So I plug in 1, I get this. Plug in 0, I get 0, 0, 0. It's 0, right? So it's just this. And now you can use, convert to fraction key if you want to. I've showed you how to actually, write this as a common denominator over the denominator 7. And then, either way you combine, don't forget your pi. Sometimes that gets lost. I keep that floating here so that we can finally multiply the 579 sevenths times pi, and that is the volume of our solid. So I hope this makes sense. Really, to do these problems, you have to draw the picture. You have to draw the curve, the region you're looking for, and then draw your disk and try and match up where's the little r if you have one, and where's the big R using the disk method. Okay.